Hey, welcome back everybody. In this lecture, I'm going to teach you about screen scraping. So what is screen scraping? Well, screen scraping, broadly defined, refers to trying to extract some type of information from a web page and put it into some type of database. So in this example here, we might be scraping the website of my university, www.duke.edu, reading that web page into our computer or to our R session, and then parsing through the source code of that web page, and we'll talk about what the source code looks like and how to navigate it, and then generating something like a spreadsheet, a CSV, that we can analyze later. So one of the first things you're going to want to ask yourself when you think about screen scraping is whether it's legal or not. In general, I advise people to use an API or application programming interface, and you can check out my other video on that to learn more about techniques for working with APIs. But I typically recommend that people seek out APIs instead of screen scraping for a few reasons. The first and probably most important one is that very often information you might like to scrape is not legally available. I'm not a lawyer, you should not take any legal advice from me, but I can give you some kind of general norms across the field. And one is to regularly consult the terms of service of the website you hope to scrape. That's a document that's typically at the bottom of a web page. It might say terms of service or terms. Sometimes there's a policy on automated accounts interacting with a page that's called robots.txt. But regardless of which document is on the web page, there is where you'll find guidance about whether you're allowed to scrape the page or not. Now, as I mentioned in an earlier lecture on APIs, when the web kind of opened up during Web 2.0, it opened up in a kind of half-hearted kind of way. So on the one hand, there was a great need to share data across websites. On the other hand, sites became acutely aware, and large companies became acutely aware of the value of their data. And so screen scraping became generally prohibited on, say, large sites such as Google or Facebook because there was enormous value attached to those data. And if someone, for example, learned to scrape most of Facebook, they could steal user data, or if they scraped enough Google information, they could try to hack Google's various algorithms. And so, by and large, many of the most popular and large websites prevent screen scraping. There's some uncertain legal jurisprudence at the moment. At the time of this video, there's a federal court hearing in a circuit, I'm not sure which circuit, but there's a circuit involving LinkedIn, the company, and another company which it had filed suit against for screen scraping. And we'll see where that suit goes, but if you want to get the latest, I would recommend checking out that any kind of new news on that issue. Otherwise, it's good practice to read the terms of the site itself, or to work with your university, if you're at a university's legal counsel, or your corporation or organization's legal counsel, to try to figure out whether you can legally scrape the page. Even if you can legally scrape the page, as we're going to see, screen scraping can be really frustrating. Simply put, screen scraping is not a science. I would love to show you 3 pieces of code that would allow you to extract whatever information you want from any type of web page. Instead of that kind of world, we're really living in a kind of world where we have to kind of get into deep into the guts of the web page and figure out precisely how the web page is structured, and more importantly, where the information on the web page we want lives. And that's going to be a lot harder than you might think, because websites not only include, say, text, but all sorts of instructions to a browser or a computer about how that text should be displayed, when it should be displayed, and so on and so forth. So we'll learn a lot about that in this lecture. The first thing you're going to want to do when you want to screen scrape a page is simply read the web page into R, or RStudio. We're going to be working with the rvest package. For those of you who may be familiar with Python or other languages, This is the R version of the famous beautiful soup package in Python. This RVest package was developed by Hadley Wickham, creator of dplyr, ggplot, and many, many other wonderful R tools. So basically, RVest is going to allow us to read in pages and then parse them or sift through them for the information we want in order to create the type of database I mentioned at the beginning of this lecture. We're going to begin by scraping a really simple page. And it's simple because it has a consistent format, and it's simple because this website, Wikipedia, doesn't have a strong policy against scraping. Incidentally, Wikipedia has an API, so generally speaking, you'd probably want to use the API instead of screen scraping, but we'll try to scrape Wikipedia in this video to try to learn a little bit about how to scrape a web page. So this is the web page we're going to try to scrape. It's the World Health Organization's ranking of health systems, and we're going to scroll all the way down to the bottom of this page, and eventually you'll see a ranking of different countries. And in this hypothetical example, a researcher wants to pull that data off on, say, not just one page, but a lot of pages. Let's say the researcher has a list of a lot of pages, and you want to programmatically or iteratively go through that list and collect tables of information, or spreadsheets, if you will, or kind of, tables of information on Wikipedia pages. So what we have to do first is understand the difference between what a web page looks like to a computer and what a web page looks like to us. So we already saw what that web page looks like to us. It has a very familiar Wikipedia logo. We kind of know where the information is laid out. There's a very regular format of a table of contents and some intro text and maybe a picture and a bunch of links. We've all seen Wikipedia, right? Now, to a computer, however, that page looks much different. That page looks like this. And this page, somewhere deep inside this long page, includes the information we're looking for, the table with the list of countries and their rank on this health indicator. But, as I alluded to earlier, this page also includes all kinds of information about how a web browser or a computer should display this page. Things like the aesthetics of the page, the font size, which type of font, the placement of the font, and all those kinds of things. So even though it's relatively trivial to read a page into R, finding the information we want on that page can be very challenging. So here's the first step to reading in the web page. The RVest package has a function called read_HTML, which allows you to pass a URL and create an object in R. I called this one Wikipedia_page. When we browse this object, we see it's an HTML document. That's one of two very common types of web data website formats. And we're going to learn now how to parse that HTML. Now, HTML is a special kind of file type in that it has a tree-like structure. So as you can see in this diagram, the HTML file is divided into a head and a body. The head typically explains the aesthetics, the formatting, the kind of global properties of the web page. The body more often includes the things we might want to scrape, things like our table. Now, our table is hidden somewhere on the body branch, if we're moving down the tree to the right here, but we don't yet know which part of that body branch it's on. Now, one option would be to very painfully scroll through the entire source code of that web page that we just looked like, or maybe try to Control F and find the information on the page. But very often our browsers are going to hide that information in an attempt to make it look more efficient and help us find the information more easily, somewhat ironically. Thankfully, Google Chrome has some nice built-in tools to help us quickly identify where the information we want to access lives on a web page. So if you go to View on your Chrome menu, drop down to Developer, and then drop down to Developer Tools, your Chrome will be transformed into an interface like this. Now on the left you see the web page, and on the right you see different parts of the source code, and on the bottom right you're seeing some aesthetic stuff. You don't need to worry about that for now. The really cool thing is when you begin to interact with the web page on the left-hand side of this tool, called the Developer tool, the relevant parts of the source code illuminate when you hover over them. And once you find the part that you think your table lives in, here I've navigated on this page to the table with the health indicators, I can then right-click on the part of the source code that's become highlighted and press Inspect. Inspect will then allow me to view the XPath or copy the XPath. The XPath is simply kind of a secret code that allows a parser to know how to break apart the HTML file in order to find one small branch in the tree. So go ahead and copy the XPath of this part of the page. And as you can see here, it's some kind of HTML gibberish that just means instructions about how the HTML should display the page. And we're going to use a function called HTML_node, which takes an HTML object, which we had created in a previous step, and breaks off the branch or node that our information lives on. So when we browse that, we see we've gotten closer, but we see we're still dealing with a fairly large chunk of the entire web page, and we want to drill down even further. Thankfully, RVest has another function called HTML_table. We can pass the node from the HTML or the branch from the HTML to this HTML table. So I called mine section_of_Wikipedia. And from that, the HTML_table function will extract any tables in that text. RVest, as we'll see later, also has an HTML_text function, which will allow you to extract text from that part of the node. And now we see the first column of the data set or the table that we wanted to scrape that includes the rankings and the countries in the page that we just saw. Now, this was fairly straightforward. This was a relatively simple case of screen scraping, and yet think of how much work went into obtaining the data. We had to first read in the web page. That was fairly simple. But then we had to interact with the web page in a fairly ad hoc way to figure out where the information we wanted lived. Now imagine you don't just want to scrape one Wikipedia page, but you want to scrape, say, 100 pages on 100 different sites, all of which have different structures of HTML, or maybe some of them are even XML, a whole different type of format. In that case, you'd have to write a custom scraper for every page. This is yet another reason why, if there's an API available for the data source that you want to access, an application programming interface, you should use that instead. Those data will probably be much more cleanly structured and also easier to collect. So very often the XPath does not yield the results that you like, particularly on more complicated pages where some type of interaction is necessary to reveal the information that you want to collect. So let's take a look at an example I hope I can scrape because it's my own university, www.duke.edu, and we want to scrape, in this case, the list of events from the home page. Super exciting stuff, right? In this case, we can use an interesting tool, which is a Chrome plugin called the Selector Gadget. And much like the developer tools, this tool is going to allow us to interact with the page in order to generate a code called a CSS Selector that allows us to find the part of the web page where the information we want lives. In this case, when you install the plugin and click the little icon, it's a little kind of magnifying glass on Chrome, you will see a search bar at the bottom of the page appear, which allows you to look for either the CSS Selector or the XPath. Those are two different types of codes we can use to parse the source code of a web page. Next, this selector requires that you click on the information that you want. Then click on anywhere on the page that includes something you don't want. Then click on the part that you do want again until only the part that you want is illuminated in green. Notice that each time you're clicking around, the CSS Selector, the little chunk of code that we're looking for, changes in that little text bar at the bottom of the screen. So once you've isolated just the green part you want, go ahead and grab that CSS Selector and then pass it into some code with the RVest package. So here's how that might look. First, we're reading in the web page. Then once again, we're using the HTML_nodes function to parse that web page. But this time, instead of including the XPath as an argument, we're including the CSS selector as an argument. And here again, you can see it's some kind of gibberish from the web page. And there you get it. We have a list of events from duke.edu today. Now you may notice in that first row of data where it says Duke Experts, a trusted source for policymakers, there is a \n\n\t. What is all that, you might be wondering? Well, these are little remnants of the web page that we kind of accidentally collected. This is very typical when you're screen scraping, to collect some type of tag from the web page, maybe an HTML tag, that's really an instruction to the computer instead of some text. In order to clean those up, you'd have to use some basic forms of text analysis, which we'll learn about in a future lecture, such as the grep family of commands. But more on that later. A final way that's become popular for screen scraping, although one that introduces some new legal complexity, is the process of browser automation. Maybe you've seen one of those player pianos before. So these are the pianos that kind of play themselves. And if you look deep inside the piano, there's kind of this slow rolling metal bar with little dots on it. And those then compress the keys through a complex system of levers. That's more or less what browser automation is going to do. We're not going to create a cylinder with holes in it, but we're going to write some code that will then open a browser on your computer, input some commands like, say, navigate to the search bar and type in some text, then scrape the resultant information from that search. So in order to do that, we might use a package called RSelenium. Now, I want to warn you about a few things before you go rushing in to install RSelenium. The first is that, in principle, you are installing some pretty powerful software on your computer. This is software that will allow you, but also hypothetically someone else, to control your computer. One thing a lot of people don't know about in the world of open source software, and in the R community in particular, is that there is no kind of grand council ensuring with a fine-tooth comb that there are no security threats deep inside our code, especially if we're installing them from GitHub. So I just want to put that out there. You probably only want to use well-vetted techniques and methods. I personally feel confident in the people who build RSelenium, but if you're trying out something for the first time, just take a look and make sure at least a few other people are using it before you share some kind of sensitive information or powerful control with the tool. Another warning about RSelenium is that it requires some complicated additional software to work with. Specifically, it needs a program called Docker. There's a link to install Docker on this page. And you may also experience some problems with Java. So Java is part of your computer's operating system. And every year, Java, a software company, and companies like Apple or Microsoft kind of have a back and forth about how Java should be revised in order to work better with different platforms. And there's a lot of kind of haggling back and forth between these platforms. And what that means is that sometimes when one installs the latest version of, say, the Mac operating system, you maybe unknowingly update your Java, and then it becomes incompatible with programs that were written for older Java. And so you may have to do a little bit of a dance to find the right version of Java to work with programs like RSelenium. Another word of warning though, if you go back to an older version of Java, you may create other problems on your computer. So in other words, don't do this unless you're pretty sure you want to try out browser automation. It could create something of a headache. In the worst case scenario, you might be reinstalling your operating system. So please do, as always, back up your stuff. So in order to install RSelenium from Docker, which is the add-on software that you have to install, you could run this line of code. And then once you load RSelenium, you create a remote driver, and that's just kind of like, think of it like another user on your machine. And then you can pass instructions to that driver. So here we're telling the driver, navigate to www.duke.edu. Once we hit this command and run it, a browser will open up on your computer, either Chrome or Firefox, depending on what you select when you set up Selenium. Then you can pass additional instructions from your code in RStudio to that browser. For example, this is how you'd tell the driver to navigate or click on the part of the web page that includes a search box. So in order to find how to figure out which part of that web page that was, in this example, I had to use the Selector Gadget to find the search bar on the duke.edu page. I then passed that CSS selector to Selenium, as you can see in this code here. Then once we're in there, we could write in whatever we want. For example, here's how we would literally type into this browser, data science, and then press return. That second \U E007 is computer speak for hitting the return button. So obviously, very often these types of skills are of limited utility if you just want to scrape one page. Sometimes there's cases where a single web page is just huge and includes a lot of information that can't easily be cut and pasted. And in that example, screen scraping could be really useful, provided it's legal. In other examples where you want to scrape a large number of web pages, you'd likely be wrapping screen scraping calls within a loop. But again, imagine the scenario where you're looking at many different types of web pages and having to write custom exception handling or instructions to your code to tell it what to do when it encounters each type of new web page. It could be a big hassle, and in some cases, it might even be easier to scrape the data by hand, depending on the size of your task, or perhaps to hire workers on Amazon Mechanical Turk to collect the information you're looking for. Again, consult with your organization's legal counsel to see whether these things are appropriate for the type of data you'd like to collect. So by now you're probably asking yourself, when should I use screen scraping? Well, the simple answer is, if there's an API and the API allows you to get the data that you want, you probably don't have to use screen scraping. It can be good to know screen scraping just so you have some basic sense of how web pages work and how collecting data from them every once in a while can be very handy. So for example, suppose you wanted to collect a lot of data on politicians from Twitter, but you needed a long list of those politicians' Twitter handles. Well, maybe you'd use some screen scraping to extract those Twitter handles and clean them up and structure them nicely, and then pass them to, say, the RTweet package to begin collecting data about those elected officials. That's a nice workflow with screen scraping. The other time I've found screen scraping to be handy is when I need information that's on an older web page. A lot of government web pages, for example, don't prohibit screen scraping, and also kind of have very consistent patterns in the way that they, say, host public health data from the state of Wisconsin in 2001 February. And you can even sometimes look for patterns in the URL and see how the URL changes. Say, if it's a page that has a lot of data for different dates, you may notice the URL just changes slightly each time. And if you can learn to identify that pattern, you might be able to write a function or some code that helps you switch that out in order to repeatedly load data. Just like rate limiting was a problem with APIs, I recommend building in posits into your code for screen scraping, just so that you don't overload the system. One final word, a lot of people may be tempted to go outside the boundaries of screen scraping and to do things that are expressly prohibited by the owners of the website. Now, as I mentioned earlier, we're in an uncertain legal climate. But for those of you who are young scholars, I would encourage you to do one thought experiment. And that is, imagine you spent a year or two collecting massive amounts of data, analyzing it, and writing up a paper. Then you were to, say, receive a cease and desist letter from a powerful organization that was threatening a lawsuit. In that scenario, you might lose all the data from your dissertation or that paper that you were hoping to get out before you go up for tenure. So I just don't want that to happen to you. So before you get deep into screen scraping, just give it a really hard thought. And also remember that now we're in a world where even though some sites might not care very much if you scrape their data, they rely upon global technology, new forms of website builders and so on, that kind of build in protections against screen scraping. So the number of websites that you can legally and easily scrape seems to be decreasing month by month and certainly year by year. So if you can find some good use cases, great. But if not, try out the XPath.